Hi everyone, this is Prachi Jain and I am going to discuss with you chapter 10 for class 10th students, that is light, reflection and refraction. We will start. You can see we are unable to see the things in a dark room. See here, this source of light, it means the light bulb is switched off and this is the eye of an observer. He is not able to see the things in this dark room. But as soon as we switch on the light, observer are able to see the things in this dark room. Actually, basically what happens here, light rays are fall on these objects and these objects are reflected the light rays, and these reflected rays when reach to the observer eye, after that an observer is able to see the things in a dark room. So what makes the things visible? So it is a source of light or the light which makes the things visible to a person. Next, reflection of light. So chapter 10 is divided into two parts, reflection and refraction. So we will start with the first part, that is the reflection of light. So you can see here also in the last slide that the light rays are incident on the object and they are reflected in the same direction in same medium, that is known as reflection of light. It means the bouncing back of light is known as reflection of light. For this, I take a plane mirror here. You can see I take a plane mirror. When a light ray is incident on this plane mirror, it reflects back in the same direction. See, this light ray is incident on a it strike on plane mirror and it goes in same direction. It got in the same medium. It return back in the medium one, or it return back into the air if the light rays travel from the air. So it return back in the air. So this phenomena is like if you are hit a ball with a ball. If you are hit a ball onto a ball, then it reflect. It comes back to you. It bounce back in your same direction, in your direction. Same here. So this is known as the bouncing back of light. Is known as reflection of light. Now we are going to the point at which the incident ray strike a plane mirror, strike a smooth surface, that is known as point of incidence. So we are making perpendicular here, that is known as normal, and the angle between this incident ray and normal, that is known as angle of incidence, and it is represented by angle I, and the angle between reflected ray and normal, that is represented by the angle R. You can see here, that is angle R. So now we will move further. The laws of reflection. There are the two laws of reflection. First law says that angle I is always equals to angle R. It means the angle of incidence is always equals to angle of reflection. And second law say that this incident ray, normal and the reflected ray, they all lie in a same plane. So for this I am going to make a plane here. You can see this rectangular, this big rectangular box, this is the plane, and the incident ray, normal and reflected ray, they all lie in the same plane. So this is our second law. So now I'm going to make a knot here. Knot is that the laws for the reflection that are also applicable on the spherical mirror. So that are applicable for all type of spherical mirrors or plane mirrors. Next topic is formation of image by a plane mirror. How then plane mirror cast image. So this is a plane mirror. In a ray diagram, we are show the plane mirror with a line, and there are some oblique lines. You can see this is the back side of the mirror, and the white side is the reflecting surface. Now I'm going to take an object here. This is an object, and we are going to take two rays. For the image formation, we need only two rays from a point source from an object. So this is the, you can see here there are the two so light rays, and they are reflect back in the same direction, but they are not able to meet with each other in a forward direction. That's why we make two perpendicular on the point of incidence, and after that we draw them in a backward direction, and they are meet at this point, and now we are make a perpendicular to this point from a plane mirror. Now this is the image of object. You can see here, this is the image of object. So properties of image formed by a plane mirror. First one is the object image is virtual. Virtual means because the image cast behind of the mirror, image is formed in just behind the mirror. That's why the image is virtual. and the second is image is erect. Uh, erect means that the image is straight. It means the image is, if the pointing side is in upward direction, then the image is also in upward direction. Image is always virtual and erect. Number two, it is of the same size. Number three, it is as far as behind of the mirror. And number four is laterally inverted. So for the formation of the image by a plane mirror, you can consider yourself when you are looking your face, when you are looking your face into a dressing table. So if you are just stand the 3 meters from the mirror, your image is also formed the 3 meters behind the mirror. And the second thing, if your height is 5 foot and 2 inches, your image is also of the 5 foot and 2 inches. And the laterally inverted, the term is used here, laterally inverted. What is it mean? Actually, basically this is a phenomena that is known as lateral inversion. The phenomena is known as lateral inversion. It means when you are looking into the dressing mirror, you can oftenly observe that our right hand looks left hand, and the left hand looks the right hand in a plane mirror. So that is known that the sideway changes, that is known as lateral inversion. It means the right side of object seems to the left side of image, and the left side of the object seems to the right side of image. That is known as lateral inversion. Now the next topic is spherical mirrors. Spherical mirrors are those mirrors whose reflecting surface are spherical. Basically, they are the part of a glass sphere, and the glass sphere is cut into the two parts, and the so that's why the spherical mirror are of the two types. If we are taking a ball, a tennis ball or cricket ball, if we are going to take, it is a hollow sphere inside. And if we are cut down into the two parts, we are getting the two parts, two half of that ball, and we are going to put the one half in upward direction and the second half in the downward direction. So we are getting the two kind of the surfaces. On the basis of that, we are having the two mirror. You can see here. Concave mirror means the white surface you can see in both of the picture. The white surface is the reflecting surface, and the red surface, that are the painted surface. So when we are taking the invert face, curved invert is as a reflecting surface, that is known as concave mirror. And when we are taking the curved outward surface as a reflecting surface, or the bulge out surface, that is known as convex mirror. So both of the white surface are reflecting surface, and both of the red surface are painted surface. Next, now I'm going to explain you some terms that are related with the mirrors. So firstly, I make a concave mirror MN and a convex mirror MN. I'm going to show you for the two of the mirrors. Now you can see first term is my pole. Pole is the midpoint of the surface that light on the surface of the mirror, that lie on surface of the mirror. So it is a part of a mirror, basically the midpoint of the mirror, and it is represented by the letter P. Second is, you can see here I will draw a point C. C is known as the center of curvature, and it is denoted by the letter C. Basically, center of curvature is the center of that sphere from which the mirror is cut out. For both the mirror, the definition is same. The distance between P and C, that is known as radius of curvature, and it is denoted by the letter R, or you can say that the radius of that sphere from which the mirror is cut out, that is also known as radius of curvature. And now the next term is principal axis. The line joining the pole and center of curvature, that is known as principal axis. So principal axis. Now the next term is principal focus. For that we are taking a row that goes parallel to the principal axis, and after the reflection it goes from a point of a principal axis, and that point is known as principal focus. So we are taking some rays, second ray, third ray, and fourth ray. All the rays are parallel to principal axis, and all the rays after the reflection they are gone from a point of a principal axis, and this point is known as principal focus and denoted by the letter capital F. For convex mirror also you can see they are reflecting, but these lines actually they are not made in a forward direction, so we draw them in a backward direction, and they all are appear to meet. I use the word appear because there is a virtual part, and this is there are the light rays are actually meet at a point, but they are appear to meet at a point, and this point is known as principal focus. The distance between P and F, that is known as, it means the distance between pole and the focus, that is known as focal length, and it is denoted by the small f. So this is the focal length. Now Mn is the aperture. Aperture, it means the length of the mirror, that is known as aperture. And there is a relation between, okay, the first thing I'm going to show you once again. Just because all the light rays that are come parallel to the principal axis, they are gone from a point of principal axis, they are met at a point, actually they are met at a point. That's why the concave mirror is also known as the converging mirror, because the light rays are converged from after reflection. And in convex mirror, you can see here the light rays are diverged, so that's why the convex mirror is known as diverging mirror. The relationship between radius of curvature and focal length is that radius of curvature is approximately twice of the focal length. And I already explained you aperture. Now the rays to be considered for drawing the ray diagrams. So there are the four kind of the rays, and we are taking the two rays for the image formation. Any of the two rays out of the four. Now you can see the first is the first ray, a ray parallel to the principal axis. After reflection, it will pass through the principal focus. I already explained this, that this is the concave mirror, focus, center, and the ray, and it goes from the focus. Similarly for the convex mirror. Second, if the any ray is passing through the principal focus, so after reflection it becomes parallel to the principal axis. And it is the reverse of first part. Third, if any ray is passing through the center of curvature, it reflects back in the same path. It means it incident, the any ray is incident from the center of curvature, it all will also return back in the same direction. Okay, so this is the incident ray. I will show it to you again. Incident, and I make the two steps again. See. So first is incident, and after that I will see here that is the reflected, and then I make the in a backward direction forward. If any ray is incident obliquely to the principal axis towards the pole, is reflected obliquely. Okay, so this is the first part. In the next video, I'm going to explain you about the image formation by concave and convex mirror.